Here we have another good lesson on circles and what are called inscribed angles. We've seen what are called central angles. You'll see them a little bit in this lesson also, but now we'll look at what an inscribed angle is and how its relationship to the measure of the arc. You'll be able to make conjectures about how the measure of an inscribed angle is related to the measure of its corresponding central angle even. First of all, we look at what an inscribed angle is. An inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So you can see I've highlighted this angle A right here. The vertex is on the circle. Before we looked at central angles where the vertex, you look at this picture down here, was at the center. But now the vertex for an inscribed angle is on the circle, and these are the chords that go through the circle that make up the sides here. So we look at angles that the vertex is on the circle itself, not in the center. Now remember, when we had central angles, the central angle measure was equal to the arc, but we'll see that this is not true with inscribed angles. We'll see the relationship in a minute. But it's called its intercepted arc. When you look at this angle right here, A, its intercepted arc is right here from arc CT here. Okay, and there's a relationship between the measure of this angle and this arc, but they're not equal. Okay, so you got to know which arc goes with this angle. So you just follow the sides, start at that point, and go all the way to where the other side hits on the inside of the angle here. So first you're just going to look at naming all of the inscribed angles and their corresponding intercepted arcs below here. So if we look at this, we've got basically three angles in this triangle. So let's start off with angle D. What is the intercepted arc for angle D? So you go up this side right here. Let me get a little highlight color here. Here's the angle D. Okay, so we start at this side where it touches not at the vertex, but where it touches these sides do, and go all the way around. The intercepted arc is this arc right here. Okay, arc OG. Erase that a little bit. Take a look at another one. Angle O here. Here's the two sides for angle O, and we can see this side starts over here, goes from G to D here, the arc, or D to G or G to D. Okay. So again, angle O, the two sides are right here. The arc goes from here to here. And the last one, angle G, go ahead and highlight it again. Angle G has this side and this side. The vertex is G here, so we don't start at the vertex. We go to these endpoints over here, and the arc goes from D to O, or O to D. Call it either way. But that arc goes with this angle G here. Okay, and we'll see the relationship between their measures in a few minutes. So go ahead and pause the video and see if you can name the intercepted arc. This is the most important thing in this lesson, being able to give it an angle, which arc goes with it. Okay, so pause it, put down your answers, and then check them. Alright, we're back for a check. Angle A, right here, has these two sides. So the arc goes from C to B, the intercepted arc. Or B to C, either or is fine. Just know where it is. Look at angle B. Right here, the two sides go from here to here. So the arc is from C to A, or A to C. That's related to this angle. AC there. Okay? And the last one, angle C. Right here, the sides go up this way and this way, so the arc is from A to B here, or B to A. Take your pick. Okay, knowing which arc is associated with the inscribed angle there. Let's take a look at the relationship now between the measure of the arc and the measure of the angle. It says here, if an angle is inscribed in a circle, then the measure of the angle is half the measure of its intercepted arc. Okay, so the inscribed angle equals half the arc. Or, I like this a little better sometimes, the inscribed angle equals the arc divided by 2. That's half the arc. So we'll be setting up equations like that. Let's look at the example coming up. Example 2. We've got given that the measure of arc BC is 100, find the value of x. So arc BC right here is 100 degrees. Let's see, let's mark that in our picture. So this arc is 100. We want to know x here, and x is the measure of this angle right here. So we look and see where is its intercepted arc, because we know now that the angle is half the arc. Well, here's the arc. We don't know what it is right now. But we learned before that what? If we take this half a circle, whoops, going a little outside there, but this half circle right here is 180 degrees. So if we take away this piece right here that's 100, we know that this arc right here is 80 that's associated with this angle right here. So now we can solve for x, because we know that the inscribed angle, which is x right here, and it's got the vertex on the circle here, so this is an inscribed angle, x equals what? Half the arc, or the arc divided by 2. The arc associated with it is 80 degrees, its intercepted arc. Whoops, I got messed up here. So let's get rid of that and do it right. Mr. Yeager was sleeping. The arc associated with it is 80 degrees, and 80 divided by 2 is 40. So the measure of this angle is 40 degrees, or x is 40. Okay? Let's look at another one. This one, there was a mistake on the paper also. It said arc AB. It should be arc CB we're looking for. This arc right here. So if we want to know this arc, we want the angle associated with it. Yep, and that matches up with this angle A here, which is 86 degrees. So this is going to be a pretty easy problem, just realizing, again, the inscribed angle, this one right here, which is 86 degrees, equals half the arc, or the arc divided by 2. So the arc is arc CB divided by 2. So to solve this, well, we want to get rid of this division by 2, so we get just arc CB here, right, by itself. So the opposite of dividing by 2 is multiplying. I show it here with just parentheses, multiplying both sides by 2. All that happens over here is this multiplication cancels out this division. We get arc CB on this side. And then we go ahead and multiply the 86 times 2 and get 172 degrees. So this is this arc is 172 degrees. Again, you can double check. The angle should be half of that divided by 2. Yeah, 86. Not too bad. Pretty easy lesson. We'll get some tougher stuff in a minute. So here we'll have a little algebra in it. It's showing us the measure of this angle is this expression 3x minus 3. And then again, we double check, take a look. All right, this angle is here. The intercepted arc is this one. So this angle equals half of this arc, or the arc divided by 2. So the angle measured is 3x minus 2, this expression. It equals the 120 divided by 2, which is 60. So now we have this equation right here, and we just solve it. Get rid of the subtraction with addition. Again, to go too fast, pause the videos. But please listen to the reasoning. Why did we set this up? Because the angle is half the intercepted arc. After that, we've got 3x equals 63. We'll divide by 3 and get x equals 21. And that's all they asked for. If they actually asked for this measure, of course, it would be half this arc, 60. You could double check that, put it back in there. Let's check some more. Next one. This one's interesting. Find the value of the inscribed angle. So the inscribed angle is z. So if I highlight that right away, I can see the arc, its intercepted arc is from x to y, but they don't give us it. So the only other information is this angle right here. How big is this angle right here? Well, this is 90 degrees. We got the 90-degree mark here. And this is a central angle. And it intercepts this arc right here too. But we know that the central angle is equal to the arc. It's not half as big. So by this central angle, we know that this arc is 90 degrees. Now we can figure out what this angle is here. It intercepts the arc that's 90 degrees, and the angle is half of that because it's an inscribed angle. So the measure of angle z equals half of that intercepted arc, or the arc divided by 2, which is 45 degrees. So here we combined a little central angle with our new inscribed angle. Again, the central angle is equal to the arc, whereas the inscribed angle is half that intercepted arc. Now this one, we'll take a little time on this one. It says if two inscribed angles of a circle or congruent circles, we could have two circles that are the same size, intercept congruent arcs or the same arc, then the angles are congruent. Basically, it's just saying, you know, if the angles are equal, it means the arcs are equal. Take a look at this picture right here. I've got a green angle right here. It's intercepting this red arc. Okay, now if I draw another angle that intercepts the same arc, I'll draw it in blue here. So then I get this angle over here. You can see this blue angle is intercepting the same arc. So since these two angles intercept the same arc, they're the same measure. You know, in this picture we don't know what they are, but if, let's say I put something like this. If this arc was 100 degrees, then we'd know this green angle intercepts it. It's half as big, it's 50 degrees. And then of course this blue angle intercepts the same arc, so yeah, it's half as big, it's 50. Okay? But that's all they're saying there. If two intercepted angles intercept the same arc, they're the same measure. And it could be the same, it could be just equal arcs. If I had another picture here of a circle, and I had this angle right here intercepting this arc, and then a blue angle, let's see what we got here. Maybe intercepting an arc over here. And if we knew that this arc was the same measure as this arc, then these angles would be equal. For instance, if this arc was 100 and this arc was 100, then these angles aren't intercepting the same arc, but they're intercepting arcs that are the same size, so these angles are the same measure. That's about all they're saying there. So we look at this example. The key is, you know, when you're given angles, seeing where the arc is that it intercepts. So in the circle, arc ST is 68 degrees. So I'll put that in. From S to T, this arc right here is 68 degrees. So they want us to find the measure of angle 1 and 2. So if I look at angle 1, one of the sides goes here, one of the sides goes here, and then finding its intercepted arc goes from here to here. Its intercepted arc is ST. So I know that the angle is half this measure. So we do that over here. The measure of angle 1 is half of 68, or 68 divided by 2, which is 34 degrees. Now if you look at angle 2, I'll color it in a different color. Let's go red here. Angle 2 is right here. You go to its sides. What arc does it intercept? Well, it intercepts the same arc, ST. So it must be the same measure. We don't even have to do the work. Of course, it would be 68 divided by 2 again, but we know it intercepts the same arc, so it's 34 degrees also. And that's what that property was talking about. Here's one that's interesting. If an inscribed angle of a circle intercepts a semicircle, half a circle, then the angle is, well, I'm not going to show you right now. I think we'll do this example 4 and you'll see what it is. Alright, so angle X here we're going to try and find. So let's see, let's get the colored pen here. Alright, X is right here. Its sides go from here to there. It intercepts this arc right here, which is a semicircle. Who remembers how many degrees half a circle or a semicircle is? It is 180. Right? So now the angle equals half this arc. So 180 divided by 2, which is 90 degrees. So then we come up here. If an inscribed angle of a circle intercepts a semicircle, how big is the angle? Is what? It is a right angle. It's a 90-degree angle. Okay? That's all that property was talking about, and we just proved it right here. We had an angle that intercepted a semicircle, and what is it going to be? Half of it. Semicircle is 180, half of that's 90. We get a right angle right there. Now we look at a pretty tough long one here. I think I'm going to pause this and call this the end of this part 1 and I want you to do work on problems 1 through 6 on your practice paper and then come back to go to video 2 and watch it. Okay? So go to your practice paper right now and do work on problems 1 through 6 and see if you need any help with those. Okay? And then you'll watch part 2 and do the last 2 problems after it.